Welcome to our Network Evolution Primer. In the next 5 minutes, we're going to discuss the architectural changes that have taken place over the last 30 years in the Baby Bells telephone networks that have set the stage for deployment of fiber to the home and fiber to the curb architectures. Specifically, we're going to discuss in this tutorial the advantages of moving the electronics from a Baby Bell central office out into the outside plant. Originally, when the Baby Bells constructed their telephone networks, every single phone in the country had a pair of wires running to a telephone switch located in a Baby Bell central office. However, as the decades passed, three big problems began to arise with this approach. First, some customers simply lived too far to be served directly from a central office. The greater this distance, the more difficult it is for a telephone switch located at a central office to drive enough current through the wires to make the subscriber's phone ring. Second, periodically construction equipment would accidentally dig up a few hundred or even a few thousand telephone lines. And third, it was difficult for the phone companies to keep track of all the wires they had in the outside plant. Also, sometimes when additional construction created new neighborhoods, the phone companies would suddenly find themselves with a shortage of pairs. Eventually, the telephone companies figured out that by taking a smaller version of the telephone switch and moving it into the outside plant, they could solve a lot of these problems. The use of a fiber link or digital T1 lines relieved network congestion by greatly reducing the number of wires that were required in the outside plant. The use of these high-speed lines also allowed the phone companies to serve homes that were located at much greater distances from a central office. And lastly, by locating the plant electronics much closer to the customer, the phone companies only needed to manage the pairs that were very close to the customer side and did not typically run out of wires nearly as often. The early versions of these miniature phone switches were called digital loop carriers and served 96 subscriber lines per box. More recently, however, telephone companies have begun to drive fiber even deeper into the network. Here we see AT&T's U-verse architecture, which deploys a fiber-to-the-curb terminal to serve a host of homes in a neighborhood. Fiber is taken from the central office all the way to this curbside terminal, and then copper wires using VDSL technology serve the last couple of hundred feet. Verizon has taken its architecture one step further and has driven fiber from a central office all the way to the home by having a dedicated terminal for each subscriber home. As is apparent, the deeper the fiber is penetrated into the neighborhood, the more bandwidth that is available for each home. In the AT&T U-verse architecture, the weak link in this architecture is these VDSL lines that connect the fiber terminal to the subscriber homes. The advantages of the AT&T approach, however, is that by sharing this terminal among multiple homes, the cost per home is greatly reduced. In comparison with Verizon's Fios approach, although the cost per home is significantly higher, the amount of bandwidth available, especially in the upstream direction, is significantly higher than that provided by AT&T's U-verse architecture. To review, the migration of electronics into the network has helped relieve network congestion, reduced the likelihood of running out of pairs, and allowed service to customers living much farther from a central office. While Verizon's Fios drives fiber deeper into the network, it does so at a greater cost per home than AT&T's U-verse network, which uses a shared architecture. Lastly, the deeper the fiber penetration, the more bandwidth that is made available to each home. That concludes our network evolution tutorial.